This is the demo for the bidirectional human-computer interface, a project we've been working on for the past 5 months. Here on this laptop we have set up a Quartz project file with the FPGA bitstream. So right now I am writing the bitstream onto the Altera DE1 FPGA board. So now it is written, and in NIOS 2 I go and run the program,
which is the Pong game.
Once it compiles, there will be an output on the VGA screen with the game already running.
So there we have the VGA screen, as well as an oscilloscope, which we will use later to show up the bitstream. Alright, so the Pong game has started, as we can see on the display, and we'll have one of the members, Ikfer, playing the game. And you play the game by activating 2 push buttons, and that way you can move the blue paddle. Alright, so now we're going to do a couple of measurements here with the multimeter. It is connected here, right here, to one of the pins on the board, and we will see what the values are. So as we can see, we have sometimes a low value, which is less than 1 volt, and a high value. And this is used to, and these values describe the action going on the VGA board. Alright, so now let's take a closer look at the PCB itself. Let me just remove these. Alright, so this PCB has an array of 25 electrodes as specified in the in our paper, and it's connected to the FPGA through the general purpose input-output, and it's a 6-pin connector. The values, the inputs and outputs are VCC, ground, we got a load, a reset, a shift, and a clock. Okay, so now let's connect one of the pins to the oscilloscope to see the bit stream going through that pin. Okay, so we have tapped into the first pin, the first electrode, and we will show you how it works with the oscilloscope.
The first pin is connected to the oscilloscope, and here you can see the shifted data that's going through the first pin. What this shifted data represents is the game board of the Pong game. Here on the VGA screen you see the Pong game taking place. The paddles and the ball represent logic high on the game board. Everything else is logic 0. So this data gets shifted and through each of the pins, and finally outputs on the corresponding pin of the game board. To make it go sideways,
you have to be on the side.
It's like hit it on the corner.
you have to have the ball on the last row and move it into its direction.
So right now we're playing the game of Pong by controlling the paddle with 2 push buttons on the FPGA.
Once it goes to the 3rd row.
So right now we are connecting one of the electrodes to the oscilloscope so that we can see the actual shifting data of the pin. So it's running.
So these are the 25 bits of the screen. There's the ones which represent the paddles and the ball. As the ball moves and as the paddle moves, this bit stream changes with time.
Now we're taking a quick look at the tongue display unit with.
And I was like, yeah, you want to see his break all the rules, just watch it.
She's on an ethics.
No, she got the blood pressure measurement device.
Oh, I see. Okay.
I was talking to her extensively about
Oh, this would not too.
so we're going to get this through over the summer to test modifications in the hospital.
which is connected with a 6-pin connector to the FPGA through the general purpose input-outputs.
Right now, this thing has no coding. It's straight off the wall. Right?
So the sensors you
Back
have,
VCC, it goes to the wall socket.
so you have interleave, ground, and
We have VCC, ground, reset, 2 data inputs, as well as the clock.
The data is shifted serially, the 25 bits through the shift registers, and then it's output.
and that's what we see on this code.
Yes.
So here in the back.
Yes, there are 3 in total, and it's an 8-bit shift register, so 24 bits in total, and then we have a wired AND, which makes up for the last pin.